In 2.1, we're going to continue reviewing some of our algebra concepts from previous courses. So the first thing I want to start with some formulas, and just a reminder, there's never going to be any formulas or formula charts or notes allowed on any of your exams. So these are things that you need to commit to memory, but hopefully this is going to be a review starting out here at the beginning. So in 2.1, we're going to be looking at linear functions. And first of all, let's kind of address what is the standard form of a line. Standard form of a line is ax plus by equal to c. And when we do this, we say that there is no fractions and a has to be greater than 0. And so when we're looking at that, standard form is like the really nice way of writing a linear equation. You don't have any fractions, your a is always positive, you've got all your variables on the left, you've got your constant on the right, and it looks really pretty. And there are times and places that our functions look like that. But typically most of the time you're going to see more of things in this slope-intercept form, because that helps us not only to see, keywords here, our slope and our intercept, it helps us to graph most easily in different situations. So it can be written as y equals mx plus b. This is going to be the one we're going to use the most, or y equals b plus mx, because remember, addition is commutative, so order doesn't matter. And so let's just kind of make a note of this. Remember, m is equal to your slope and b is equal to the y-intercept. And so when we have it in this form, it really makes our life nice for us, because it gives us a good, let's note this, starting point to when we begin to graph something. We can go ahead and plot that y-intercept, and then we can do our slope from there. So I want to kind of start with that and just kind of work with an example, and then we're going to define it out. But again, this is going to be review for you now that you're in pre-cal. You've had those courses before this. And so it says write the equation of the line in slope-intercept form and graph the line. So the first thing you want to do, you'll notice that this is in standard form, but the best thing we can do is to get this in slope-intercept form, because although this is really pretty and nice, it doesn't necessarily help us to graph the easiest way. And so I'm going to just go ahead and solve this thing out for y. So I'm going to subtract the 3x. So it gives me 4y equal to negative 3x minus 16, and then divide everything by 4. Now, we do not want to run to our calculators and grab a decimal. We always like a fraction in lowest reduced form, and the reason of that is also here for graphing reasons. And so you always want to start with this y-intercept of negative 4. And so I'm going to go down, let's see, 1, 2, 3, 4, and go ahead and start there with my dot. And then from that point, we're going to do our slope, which is negative 3/4. And so that means we're going to go down 3. So that would be 1, 2, 3, and over 1, 2, 3, 4. If we're graphing a straight line, once we have 2 points, we've got our straight line. And so you can see that's what this line would look like. We were going down negative 3 from our slope and over 4. And so just to kind of recap some of those things with slopes, let's kind of write out what we just did with that. And so slope, remember, it's equal to rise over run. It tells you how much to rise, either up or down, and then you always run to the right. This is your change in y over your change in x. This is delta y over delta x. As you move forward, that delta or that triangle sign, you're going to see a lot more. Here's the one you know, y2 minus y1 over x2 minus x1. And this can be written as y1 minus y2 over x1 minus x2 if you like. Whichever one you want to put first, you're still going to get the same slope. But this is not equal to y2 minus y1 over x1 minus x2. Whenever you're doing your slope, you want to make sure that these pieces are lining up, your y2 over x2 or your y1 over x1. You want to make sure those are all perfectly lining up, that this is that ordered pair that you're working with. But you can see in this very last one that is not equal, here's my y2, and then here's my x2 that is the ordered pair that is paired up with it. There's your y1 and your x1. You can see that that one does not work out. So I want to kind of emphasize that you do want to put vertically the ordered pairs that you're using. And so hopefully you're pretty keen on that slope, and it's just kind of a review as we're going throughout. Now there's going to be 4 different kind of slopes that we're going to encounter. We're first going to encounter one that is increasing. So this would be my increasing slope. You can see it's going up, so that would be my positive slope. We've got this one is going down. This is my decreasing slope. I've got a horizontal line. This is going to be my 0 slope, such as if you had gotten maybe, just an example here, 0/3, that would be equal to 0. If you ever forget, just punch that in your calculator. We don't say no slope or doesn't have a slope. It is 0 slope. And then we've got this one here that is undefined. And those are going to be the 2 ways that you use that, 0 and undefined. There is no other words that we're going to use with those 2 slopes. An example of an undefined one would be equal to something like 3/0, and if you go into your calculator and type that, it would say undefined or error cannot divide by 0. So that's a good hint. If you can't ever keep these last 2 straight, is use your little calculator, type that in, and it will help you to finish that out. And so we're going to kind of visit that as we move forward with some of these lines as well. So we have an idea of slope. We've got our slope-intercept form. The next one is probably the one that I use the most, I would say, in my solving and moving forward in other courses and creating lines. And that would be the one of our point slope form. Point slope form looks something like this. You have y minus y1 equal to m of x minus x1. And it follows suit of, it is a point. So whenever you have a point and a slope, you can create an equation of a line. In the previous one, y equals mx plus b, that looks really good when you have a y-intercept and a slope, just like the name, slope-intercept. But if you have a point and slope, I prefer this one because this is where the least mistakes happen, and instead of going back to my y equals mx plus b, and everything kind of flows out really nicely. And so let's kind of do an example of working with one of these. It says, write the equation of the line with a slope of -3 and passing through 4, 8. So the first thing I would do, I would label what I have been given. And this is going to be my m. Here's my x1 and here's my y1. That's the first x I have. That's the first y that I have. Next thing I'm going to do is I'm going to write my formula. Y minus y1 equal to m of x minus x1. So I always write my formula. The more you see it, hear it, do it, the more you retain it. Then I'm going to fill in everything that I know. Now I already have my slope to be m, and I already have my x1, y1 to be 4 and 8, and so I'm going to plug in those values for the letters I have written down here. So I always like to now, in my next step, write what I know, y minus equal to parentheses x minus, and so there's kind of my template that I'm going to be plugging into here. Then I'm going to plug in the values that I highlighted here. So let's see, y1 was 8, and m is -3, x1 is 4. Once I have it filled into my point slope form, I just have 2 steps from there. I'm going to distribute, so it gives me -3x plus 12. Be careful with those negatives. And then I'm going to move that -8 over, so I'm going to add 8 to both sides. So this gives me y equal to -3x plus 20, and then I could just take that information right there, and I could go and I could graph this if I wanted to on a graph. And so you can see that point slope form is really nice, because once you plug in that point and slope, you just got to distribute, and you move over, and you already have this equation in slope-intercept form now. So I really like that, and you're going to see that moving forward. And even in calculus, which comes after your pre-calc class, we're going to keep using that equation. So be able to create an equation of a line as something you just never get away from. So let's do another example. This one is given 2 points, and it says find the equation of the line passing through the points. And so we're going to have to do 2 things. We have 2 points, so the first thing we need to do is find slope. So step 1, find the slope. They didn't tell you to do that, but in both of those equations that we just looked at, we had slope. So that's what we need to do. So I'm going to write my formula. M equals y2 minus y1 over x2 minus x1. And whenever I have all these letters going on, I always want to come up here and label. So this is x1, y1, x2, y2. And I did that because that's the first x I see, that's the second x I see. So I just kind of do them in order. And then I always like to write my slope formula without any of my letters in there, and that's so I don't forget those negatives in there, because a lot of students forget that. And then I'm going to plug in what I have labeled. So let's see, y2 is -3, y1 is 4, x2 is 1, x1 is 3. Once I have them all plugged in, I'm just going to use my calculator if I need assistance with negatives, but -3 minus 4 gives me -7, and 1 minus 3 gives me -2. So this gives me 7 over 2. You always want to put them in lowest reduced form. I'm not going to leave that as -7 over -2. That's going to make my life difficult. And I'm not even going to run my calculator and put in 3.5. I want to leave that as an improper fraction. So after I find the slope, step 2, I'm going to plug one of the points in and slope into the equation. And so remember that equation that we have, and right here, this 1 point plugging in, it doesn't matter which one you want to choose. I typically kind of just go to the first one since I already have it labeled. And so let's see, first thing I'm going to write my formula. Y minus y1 equal to m x minus x1. I'm going to rewrite that without those letters filled in, just so I get all my parentheses and negatives in the right spot. And then I'm going to come up here, I'm going to take this information. And so I'm going to take first this x1, y1, and I'm also going to take this 7/2 m. And so that's going to be the information that I plug in down here. So let's see, y1 was 4, m was 7 over 2, and then x1 was 3. And so now I got 2 steps. Distribute. So it gives me y minus 4 equal to 7/2 x minus, let's see, 21 over 2. Use your calculator to help you out with that if you just dread working with your fractions. And then I need to add this 4 over here to the other side. And so then that gives me y equal to 7 over 2x. And now I gotta do some fractions. Negative 21 over 2 plus 4. So I need to turn that into a fraction. So that would be equivalent to 8 over 2. So if you combine your tops, that gives us negative 13 over 2. So minus 13 over 2. And I'm going to leave it just like that. You always want to leave your answers as an improper fraction in lowest reduced form. I'm not going to go in there and turn it to a mixed number. And I'm also not going to go in there and turn it into a decimal either. So I hope this helps you get through section 1 of chapter 2. Just feel free to Canvas message me if you have any additional questions, comments, or concerns.